Hello everyone and welcome back. Today we're going to speak about the development of the atomic model. Our idea of the atom didn't simply originate in a vacuum, but rather it went through many different revisions by many different scientists through thousands of years. The first people to be credited with the atom is, of course, the ancient Greeks. Democritus postulated that if you keep breaking matter, you're going to reach a point where you can no longer break it any further. Hence the idea of atom. Atom simply means indivisible. But they had the wrong idea. They simply said that there are four different types of atoms: earth, wind, fire, and water. This was, of course, very erroneous, and the first model was developed by Dalton. Dalton hypothesized that atoms are made up mostly of tiny stellar spheres that are indivisible, incomplete in themselves. This is called the solid sphere model. As you can see in the picture, it is simply a circle, a sphere that is simply filled in. The four tenets of the Dalton model include the following. All matter is made up of particles called atoms. Atoms of the same substance are identical. Atoms of different substances are different. And compounds are combinations of different types of atoms. These are very, common sense things that we now know, but back then, this was not very easily understood. The idea of the atom was further developed by J.J. Thomson. J.J. Thomson discovered electrons through the cathode ray tube experiment. He described atoms as positively charged spheres that are solid with negative charges embedded in the surface of the atom. He called this the plum pudding model. As you can see in the picture, just as the plum pudding has random plums embedded on the surface of the pie, the same way electrons are randomly embedded on the surface of the atom. He came up with the idea after conducting the cathode ray tube experiment, where he took Crookes tube, which is simply an evacuated tube with nothing in it, not even air, and he applied a voltage potential across each side of an electrode. He then observed a beam of particles that originated from the cathode and went all the way to the anode. He then put the Crookes tube in an electric field, and he noticed that that beam of particles would bend towards the positive. So he said, whatever made up the beam of particles must be negative, and he called those particles electrons. A major furthering of our understanding of the atom came by Rutherford, Ernest Rutherford. He basically described atoms having a positive nucleus, so all the mass is located in the center, and the atom is made up mostly of empty space. The name of the model is called the nuclear model, and as you can see in the picture, we basically have all the masses located in the center, which is positive, and we have a lot of empty space where the electrons are present. He came up with the idea after conducting the gold foil experiment. He took a radioactive source and he put it inside a primitive particle accelerator, which was simply a lead cube that he drilled a hole to the side, and he shot these alpha particles in one direction against a thin gold foil. Gold foil is exactly what the word basically means. It is a thin slice of gold, just like the tin or the aluminum foil that we have in our homes. And all around the gold foil, he put this fluorescent screen, and whenever a particle would simply fall on it, it would produce a bright flash. So let's see what he expected. If atoms were solid, just like his predecessors claimed that they were, what would happen? The vast majority of the particles would actually bounce back and would not go through the gold foil. But to his surprise and his amazement, he found that over 98% of the particles went right through the gold foil, completely undeflected, and only a very small portion of them, less than 2%, got deflected, and they struck the fluorescent screen at different areas. So he hypothesized that the reason why the majority of the particles went undeflected right through the gold foil is simply because they found empty space and there was simply nothing there, so they went right through it. But on the other hand, the ones that got deflected were because they struck the nucleus, which was made up of solid matter. He very accurately described the structure of atoms in such a way, and now we know that the volume really of an atom consists pretty much 1%. All the mass is located in the center nucleus. The next furthering of the understanding came through, the Bohr model. He basically said that atoms consist of solid charged spheres, and negative electrons orbit now the nucleus in concentric orbits. We call this the planetary model. And as you can see in the picture, we have again the solid nucleus, and electrons are in prescribed paths and they orbit around the nucleus. Hence the word the planetary model. The newest model that we have is called the wave mechanical model or the orbital model. It simply says that atoms consist of a solid positively charged sphere with negative electrons located in orbitals. Orbitals are regions of space around the nucleus where the probability of finding electrons is very high. So in other words, they're no longer in a pre-described path, but rather their distance to the nucleus changes and it behaves just like a wave, as you can see in the picture right in front of you. Thank you so much. I'll see you in class.